Hello, this is a test showing different grids from a spherical perspective. So right now you are looking at a grid that is 1 unit ahead of you. You are at the center of a sphere, and you can look around right now with the WASD keys if you want to. There are equations in the background and a grid in the front, and that way you can look at the grid with perspective and see very common graphs. So we're going to start off with y equals x. And one thing you might notice about this graph is that if you follow the black line, which is representing the graph, and you look as it goes to the right or as it goes to the left, they are approaching what looks like points vanishing out into the distance. These vanishing points correspond with a line having slope 1. So if we pick a different linear equation, also with slope 1, like y equals x plus 2, you'll notice that it also intersects these same vanishing points. So this graph here, 2x minus 3, have different vanishing points. So if you look, you might notice that they are now approaching different points on the plane as you look further, the slope 2 points. Now on the projective plane, these points would technically be the same. However, we can't really illustrate this given what we have. However, you're looking in opposite directions to see those points. Now, x squared, the slope goes up linearly, so the slope will eventually get to infinity. So that's why it converges to the top. And it kind of looks like you're staring at an ellipse, because when you look in the projective plane, a parabola and an ellipse are the same type of thing. And then if we move that parabola around, it would still go toward that same point at infinity way up at the North Pole in this illustration. However, we'll go through different points. The x cubed will go toward the top and the bottom because it's an odd equation, but once again, it will still go toward the points at infinity with infinite slope. Here's a circle. That's quite cute. And now we're going to go on to some trigonomic equations. This is sine x. So you can notice this squiggly nature, the periodic nature, and it appears to converge to this one point this time because it stays basically in the same spot, but it just gets infinitely more squiggly with perspective, despite the fact that it actually stays the same period on the plane. Cosine x is quite similar, just at a different starting point. Now, tangent of x. Well, this doesn't play that well with this Desmos graphing thing that I'm trying out because, well, it's getting kind of messy and not all the grid lines can be seen. I was hoping for this one that because there are infinitely many lines that go toward infinity in both directions, that you would all see them converging at the top and the bottom, but it doesn't look like that's happening here. However, the arctan function is a lot nicer with this simulation, especially given the format that it's in. If we go to e to the x has intrigued me because the way e to the x differentiates between positive and negative infinity. The limit in negative infinity is 0, but the limit in positive infinity is positive infinity. So unlike other equations, it doesn't actually approach the same number in both directions. And you can see this, how it approaches 0 in one direction and then it goes to the top in the other. If we do natural log of x, that is another equation that is very similar. However, it's interesting that it stops. Now, I wonder how this looks in the spherical view. Now, I tried to do factorial. Factorial is quite a crazy function, so I'm not sure how it looks. You probably can't see much because not much of it has rendered. However, there's bits of it that are kind of all over the place, and it doesn't help the fact that the grid is only 1 unit away, meaning that lots of the details are kind of far away from the center and you have to kind of graze around the center to be able to see anything. One funny thing that I noticed is that if you take the arctangent of the tangent of x, you don't get x back. You get this kind of periodic linear thing that has to do with x, which kind of makes sense because the arctangent function, to be a function, has to be within a certain area. One thing that I forgot to do while doing this was to do 1 over x, which is pretty intriguing because it apparently is not defined at x equals 0 because it goes to in positive infinity from the right and negative infinity from the left. On the real projective plane, these 2 points are the same. However, in the spherical view, they are not the same point. You have to look in the opposite direction to see them. Mathematically, they're very similar. 1 over x squared is different because both sides from 0 approach positive infinity. So it can be said by more people that 1 over x squared actually has some type of limit when you go towards 0. Now, in order to make these visualizations, I needed to make the grid, which I did in Desmos using these rather nightmarish equations. I don't have enough time to explain the logic behind these equations, but once you have them, you can graph pretty much anything that you want if you substitute all your x's for tan x and all your y's for tan y times the square root of the tan x squared plus 1. And that way, when you do any sort of equations, they will map onto the grid in the right way. However, one thing you might notice is that they also map in places that aren't desired because of the periodic nature of all these tangent functions lying around everywhere. So better watch out for that. And Desmos may not be happy about the amount of computation that you're asking it to do.